I'm Gayatri, working as Assistant Professor in EC Department at SNS College of Technology. Today I'm going to discuss about the topic continuity equation under the Unit 2 Electrostatic Fields in Conductors and Dielectrics, studied by second year students in the semester, fourth semester in the subject Electromagnetic Fields and Waves. Before going to discuss about the continuity equation, we have to know about the law of conservation of charges. And topic for the discussion today, I am going to discuss about the law of conservation of charges and what is a current flow and charge density is how it is related, and mathematical expression related to the continuity equation, which is in the form of integral and differential form, and where the continuity equation will be used, physical significance will be discussed in detail, and the applications of electromagnetic field in the continuity equation. And coming to the empathy part of continuity equation, the continuity which represents, for example, when there is a water flowing through the pipe without any leakage, there will be a continuous flow in the water in the pipe. And in the traffic junction, the number of vehicles entering and number of vehicles leaving at the junction will be equally, there will be a flow. And in a common one room, how many peoples are entering and how many peoples are leaving the room, it will be related with the help of continuity equations. In the continuity equation, we have to visualize the flow dynamically in the real time scenario. And coming to the defined part of the continuity equation, the continuity equation will be revealed with the help of law of conservation of charges. The law of conservation of charges, which is nothing but the charges can be created, not destroyed. How? In a conductor on an electric field, how many amount of charges will be created, the same amount of charges will be destroyed. Where it is nothing but there is a decrease in the rate of flow of charges inside the conductor. In outside the conductor, there will be increase of rate of flow of charges in the conductor, and it will be related with the help of current density and charge density. The charge density will be related with the help of rho, and current density will be related with the representation J vector. And J vector, which is nothing but it is related with the help of current. And it ensures that when there is a charge decrease and the current flow will be there due to the decrease of charges present in between. And coming to the defined part, that is the mathematical expression related to the continuity equation, is that it is related with the help of differential form and integral form. In the differential form, it will be related with the help of current density J and charge density, volume charge density rho, and rate of change of charge density will be represented as d by d theta, and minus, which represents there is a decrease in the rate of change of charges present inside the conductor. So that the differential form will be related with the help of del dot J vector, which is equal to minus dou rho by dou t, where J represents current density, we know rho represents charge density, and d by dt, which is a rate of change of charge density in that particular medium. And coming to the integral form, it will be related with the help of charge density. And physical significance of the continuity equation is that if the charge density is decreases in that particular region, there will be a current flow increases. The current flow will be flowing through that region or conductor. If charge density increases, the current flows will be in, that is inside the conductor there will be a current flow. When the charge density decreases, the current flows out, which is coming outside the conductors. For steady state current, that charge density will be 0. So that in a differential form, it will be related that del dot J vector, which is equal to 0, by d rho by dt, which is equal to 0, shows that the current will be continuous in the steady state system. And coming to the application part of continuity equation will be used in the current, how much amount of current flowing in the conductors, and we can analyze how many vehicles will be entering in the traffic junction and how many vehicles will be leaving in the junction. And it is a basic for Maxwell equations, and it is used for semiconductor device modeling. And by the applications of law of conservation of charges, we can use for analyzing of charge density, and it is applicable for electromagnetic field theory. And coming to the summary part of the discussion, the continuity equation which will be related with help of current density and charge density. And it will be related with help of mathematical form, differential form and integral form. And applications, it will be used in current flows in the conductors and semiconductor device analysis. These are the references I have taken for the continuity equation. Thank you.